All right, good morning, good morning, good morning. We'll get started in about a minute, 1 minute. Morning, Caitlin. All right, here we go. Here we go. Good morning, Caitlin.
Good morning.
Not in the car today?
No.
Good job watching the video live in the car. That's heads up. All right. We are going to start on the most important chapter of the book. And the reason why this one is the most important one is because it deals with negative numbers. So from every single course, from 8th grade all the way through college, every single problem, almost 99% of the time, from 8th grade onward, deals with negative numbers. So you have to know how to add, subtract, multiply, and divide with negative numbers. And it turns out completely different rules than add, subtract, multiply, and divide with positive numbers. The rules change. So it's almost like starting in chapter 11, we're back to kindergarten, first grade, third grade, fourth grade, where you learn how to add, subtract, multiply, and divide. Good news, bad news. Bad news is, yeah, they're brand new rules. And kids take a while to memorize these rules. This isn't like, one class, and, oh, I got it now. It's going to be multiple classes. We're going to spend the majority of quarter 4 on dealing with how to add, subtract, multiply, and divide with both positive and negative numbers. We have to learn those rules. And my goal here is not necessarily to make you memorize the rules. It will happen. Many of you will have them memorized. But the goal is by the end of 8th grade that you have them memorized. Like, you don't have to think about it. You just do it. And my track record for this is really good. Like I will have kids in 7th grade that can do it. They certainly don't have it memorized. We get to 8th grade and boy, they're like, I mean, you look at all my 8th graders now, none of them have any issues with add, subtract, multiply, and divide, positive and negative numbers. And so you guys will be just like them next year. This time next year, you won't have to think about this. But this year, some of you, not many of you, but some of you will really need to think about these problems when you do them. I said the good news, bad news. Well, the good news is the chapter starts off today with a pretty easy section. So there's nothing challenging about today, but I'm just going to warn you, when we come back from this weekend, Monday, we're going to start with addition, and we're going to spend 3 days on doing nothing but adding positive and negative numbers. Yeah, the rules are that strange that it's going to take us 3 days to learn how to add 2 numbers together. The difference is either one or both of them will be negative. And then we'll do subtraction, then we'll go on spring break. We'll come back, do a quick review, get back to subtraction, and then we'll do addition or do multiplication, division. Turns out multiplication, division are the easiest rules. Paradoxically, that was the hardest thing to learn when we were doing numbers, but adding, subtracting ends up being the most complicated rules. But enough of that. I said today is easy. Let's see. So here's your homework for tonight. It's basically 3 things. These are all going to be new too today. You have not had any of the stuff I'm going to teach you yet today. But it is pretty easy. Monday is when the hard part starts. Or sorry, Tuesday. Keep thinking Monday's not for it's a work day for me, but you guys have off. I forgot to look. I'm going to look real quick here while you're copying that down. Let's see who has not turned in their test. It might be a couple of them that turned in. I haven't graded. I tried to grade them all yesterday, and then around, I don't know, 7, 8 o'clock last night, I went to bed, so I stopped grading if you turned it in after 7 o'clock or so. Let's see. Now, some kids may not have actually, because they're doing the test today, they're 24 hours behind. So, Kaylin, I don't have a test from you. Grace, no test. Richard, no test. Ariana, Maddie, Madison. Madison sent me a email. We discussed for her what she's going to do. Macy, you don't have your test. Caden, I don't have your test. Antonio, I don't have your test. Connor, no test. Nathan, no test. Eleanor, no test. And David and Soraya, no test. So obviously this is Friday during the normal time when I'm making this video. So if you watch this video this weekend sometime, you're like, wait, I know I turned my test in on Friday. Well, just all you got to do is go back on Teams or on Infinite Campus and check, or sorry, Power School, check to see if I have it graded yet or not. I will have anyone that turns it in graded today. All right, back to the matter at hand. Negative numbers. Here we go. Negative numbers. We're going to do 3 things today. They are all brand new. I'll describe them as we do them. Think about this, right? Way back in kindergarten, first grade, you learned how to add numbers, single digit numbers. And I'm going to guess that most likely the way you learned it initially is they gave you a number line. They didn't say memorize 3 plus 4 is 7. What they did probably was give you a number line. Remember, on a number line, numbers get bigger as we go to the right. And what they probably said is, well, look at the first number. The first number there is 3. And plus means get bigger, and it means get bigger by the second number. That's what addition means, get bigger, right? Get bigger by 4. So we don't go to 4, but we get bigger by 4 more units. So we count over 1, 2, 3, 4, and whatever number you wind up with, in this case, 7 is the answer. I'm betting this is how you learned initially how to add. Now, at some point, you did actually memorize that 3 plus 4 is 7. Okay, but when you first started out, you actually had to count that out. It turns out that addition with negative numbers does not work this way. We will have to start on Tuesday, learn a new method. But in order to do that, we're going to quickly just review some basic concepts. And one of them is how normal addition works, like this. All right. Subtraction would be the inverse of that. You learned it the same way. You didn't memorize 5 minus 2 at the start. They said take a number line, start at 5. Remember, numbers get smaller when you subtract. We start at 5 and we're supposed to take 2 away. In other words, move 2 units to the left of 5. 1, 2, and we wind up with 3. So there is your basic welcome back to kindergarten, first grade for addition and subtraction. And I'll say it again, it turns out that subtracting with negative numbers does not use this. So our old methods of thinking about addition and subtraction end up not being very useful when we are involving negative numbers. Of course, that all begs the question, what are negative numbers? So that's how we will choose to start this discussion of what are negative numbers, okay? And the issue is this. The issue is that, well, subtraction means get smaller. Well, if we start at 5 and we get smaller by 8, we count over 1, 2, 3, 4, 5. We run out of numbers on our conventional number line. So the number line that you had in kindergarten, first grade, all the way through up to this point right now, did not allow you to do 5 minus 8, okay? So we will make a new number line now. In fact, it will be a more total number line that will include all the numbers that we will use from now on. So today's class, yes, we'll have the normal number line, 0 through 10, so forth and so on, but we will continue to the left. We will continue to get smaller. These are where the negative numbers live. They live to the left of 0. They are all numbers that are smaller than any positive number or the number 0 itself. The number line visually looks the same as the positive number line. It just, we put a minus sign in front of all the numbers to indicate negative, okay? Cool. So the whole chapter deals with this number line right here. Now we'll be dealing with bigger numbers than 10 or negative 10, but the entire chapter deals with add, subtract, multiply, and divide with negative numbers and positive numbers. And as you'll see, we need new rules. All right. So the complete number line, the first thing I want you to put in your notes is the complete number line. The complete number line, well, it's a number line. That means there's a line involved, arrows on the ends. The middle of our complete number line will be, in fact, still be 0. Now remember, we didn't have a middle of a number line when the numbers were positive, but we will now have a middle for our complete number line that will be 0. By the way, 0 is neither a positive nor a negative number. 0 is just the idea that you have no value. All right, positive numbers live to the right of 0. Right? If I put a number right there, it could be 1, it could be 10, right? And then negative numbers live to the left of 0. So if I put a tick mark, an equal spacing as 10 was on the other side, that number would in fact be negative 10. Okay. Now you're probably more familiar with more tick marks on your number line, and feel free tonight for homework to put as many tick marks as you'd like. Halfway between 0 and 10 would be 5. Halfway between 0 and negative 10, Caitlin, would be?
Between 10 and negative 5?
0 and negative 10.
Negative 5?
That right. There you go. Okay. So like I said, we can put more tick marks. We can go up or down by 1 as well too, but that's the basic relationship. The basic relationship, the numbers get bigger as you go to the right, and numbers get smaller as you go to the left. The negative numbers are to the left of 0, and the positive numbers are to the right of 0. All right. Couple of quick notes on negative numbers themselves. So this year, our book, when they indicate a negative number, they won't put the negative number in the middle, they'll put it at the top on the left side. So that's how negative numbers look this year. I believe it does a disservice to students because 8th grade and onwards, the negative number or the negative portion of the number stays in the middle. And so it literally looks like -5. And the basic concept, -5, -5, are basically the same. You can either read that as subtract 5 or -5. Either one is fine. Okay, but this year, a little bit confusing. The negative will go on the top here. You will see in most of my presentations for this year, I will also put the negative on the top here, but occasionally even I slip up, I forget, and I'll put the negative in the middle. There's a couple times during this presentation. Unfortunately, it's just the way math books, they want to get you to the idea of negative numbers. That's why they differentiate it this year, but not next year. All right, so our number line with both positive, negatives, and 0. I do want to make this one last point. Occasionally, I'll get a student that will think of -10, and they will think of it in comparison to, say, -5. So if you think about these two numbers, -10 and -5, because you're used to dealing with positive numbers, that 10 is in fact bigger than +5. But it turns out, because it's a number line and numbers get smaller as we go to the left, that -10 is actually smaller than -5. And we're talking value here. We're not talking about the number. I mean, 10 is bigger than 5, but -10 as a value is actually smaller than -5. Why? It lives to the left of -5 on the number line, and any number that lives to the left of a number is smaller. All right, so the point here is that the numbers get bigger on the negative number line. So by bigger, I just mean the number itself. So for instance, -1, -2, -3, the number is getting larger, but the value of that number is actually getting smaller. Okay, questions on that? Okay. So where are we doing? I already said this a couple times. This entire chapter deals with negative numbers and positive numbers, but mostly negative numbers. And then how do you add, subtract, multiply, and divide with those negative numbers? And more importantly, how do you do that with a combination of positive and negative numbers? And it turns out that there are rules for all of this. One extra thing that the chapter will throw in at the very end is graphing with negative numbers. But usually that's a minor part. No one ever has an issue with that one. But add, subtract, multiply, and divide, oh yeah. You will have a big resource card with a whole bunch of rules for add, subtract, multiply, and divide because they're new to you. All right, some more background information. Write this down, please. First definition, opposites. In math, when you are opposite another number, it means that you are the same distance away from 0 as that other number. Opposites come in pairs. Two numbers are opposite each other if they are the same distance away from 0. A little bit easier to do with a number line. Pick a number, Caitlin.
Does it matter what number?
Nope.
-3.
All right, so -3, right? -3, I lost my mouse here. -3, come back, mouse. There you go. 3 is right here. And 3 is how far away from 0, Caitlin? How far is 3 away from 0?
Oh, 2.
It looks like it's 2, but if we actually count 1, 2, 3, it's 3 tick marks away. There's another number that it's also 3 away from 0. What's that number? No, it's not 6. 6 is 6 away from 0. What's another number that's 3 away from 0?
-3.
Yeah, -3 is also 3 away from 0. And that's this idea of opposite. Opposites are two numbers that are the same distance away from 0. Okay. So to create an opposite or to find an opposite, right, all we do is pick a number. I'll pick a number here. Let's say 5. What's the opposite of 5, Caitlin?
-5.
You got it. So 5 and -5 we call opposite of each other. Why? Because they are the same distance away from 0. And that's how that game is played. Okay, so -5 and 5 are opposites. Second point, and remember this is still background information. We talked about at the start of the year something called natural and whole numbers. If you don't remember, natural numbers were numbers that go up by 1 and they start at 1. So 1, 2, 3, 4. These are also called the counting numbers. If you include 0 into that list of numbers, we call that set of numbers the whole numbers. Today, we get that more complete number line. We're going to add negative numbers to this. And so, well, let's define both positive and negative numbers first. So positive numbers are numbers that are greater than 0. They would include fractions and decimals. So for instance, 1/2 is a positive number, so is 2. Any number to the right of 0 is called a positive number. Well, the opposite of a positive number, therefore, would be?
Negative number.
And negative numbers don't live to the right of 0. Negative numbers live to the left of 0. Okay, and so negative numbers would be, to include decimals and fractions, would be numbers that live to the left of 0. Now I'm going to switch gears. Now what I want you to consider are just the numbers that are visibly on this number line right here. So notice there are no decimals, there are no fractions, there are just the counting numbers, 1, 2, 3, 4, 5, 0, so that's the whole numbers, and the negative numbers that are, I don't know, the opposite of the whole numbers. So if we consider that group of numbers, no decimals, no fractions, we get to the numbers that we will use in this chapter, and those are called the integers. So the integers are the positive numbers, their opposites, and 0. Okay. Now, yes, there are negative fractions, there are positive fractions, but we're just going to consider the numbers that aren't fractions or decimals. So that would be the whole numbers or the natural numbers, their opposites, and 0. 7th grade doesn't make too much a differentiation between integers and the decimal numbers, but in 8th grade we will. All right, so this entire chapter we're going to be dealing with integers, how to add, subtract, multiply, and divide them. We okay to go on?
Yeah.
Okay. All right, so here come the new ideas. The rest was, well, integer is a new idea as well too, but not too complicated. But here come the new ideas. All right, this is the big one. You're going to see this a lot in higher level math. This is called absolute value, and it actually has a symbol as well too. Absolute value is not opposites, but it's how far are you away from zero. Remember, opposites were two numbers that are the same distance away from zero. Absolute value is just simply how far are you away from zero. I said it has a symbol, right? It has a symbol, and there is the symbol. So the symbol isn't the number line. The symbol are these two vertical segments. They look like parentheses. In all practicality, they act like parentheses. The difference is they're not parentheses, they're absolute value. Absolute value asks how far is what's on the inside away from zero. So how far is 5 away from zero?
5.
Yeah, the answer is 5. So if you have to count 1, 2, 3, 4, 5, it's 5 away. Well, what's the absolute value of negative? It's red, the absolute value. What's the absolute value of -8 if the question is how far are you away from zero?
8.
It is 8, right? Because it's the same question. So notice what happened. Whether what's inside is positive or negative, the answer is always positive. So whenever you have an absolute value question, well, the answer is always positive. Not the same for opposites. Opposites, the answer could be negative, but for absolute value, the answer is always positive. How far are you away from zero? Well, you're a certain number of units away. So here's your first brand new welcome to higher level math. We get a symbol and we get a concept. The concept is absolute value, and the symbol are these two vertical lines or segments that look like fractions, or look like parentheses. Oh, it's a Friday. All right, believe it or not, they're going to ask you some questions. One of the questions is literally take the absolute value. So what's the absolute value of 2?
2.
That's pretty simple to do, right? And it simply is, how far away? The absolute value of -3?
3.
Yeah, and I don't want to, bore you with this, but that's literally all you're doing. So it's pretty simple to see all the answers. The last one's a bit more interesting. What's the absolute value of 0?
0.
Because 0 is 0 units away from 0. So absolute values are not that challenging, not that difficult. There is, if you have a scientific calculator, there are parentheses and there are absolute value symbols as well too. You just kind of got to look through your menus to find the absolute value symbols. But to actually do it in your head is pretty simple. You just say how far are you away from 0. Okay, that was our first of 3 games. Literally is just simply to take an absolute value. All right, next game. They're going to give you a series of both positive and negative numbers, and they will ask you to put those numbers on a number line. So putting those numbers on a number line. Caitlin, can you kind of figure out what would be the best technique to do this?
Not really.
Okay, here's the best technique. We look at all of the numbers. We find the smallest number. What's the smallest number?
-2.
-2 is the smallest number. What's the biggest number?
4.
Those will be the starting and end points of my number line. Now we read from left to right. You could do this from right to left, but we typically read from right to left. So you're always going to start with your smallest number. Well, my smallest number here is -2. So on my number line, -2 is going to be my starting point. And then I simply count up to the largest number. The largest number is 4. And I'm going to go by ones. So the next number would be?
-1.
And so forth and so on until you get to the largest one. Now, what'll typically happen is that we'll run out of space. But the cool thing is, instead of starting at one end or starting in the middle and having to do a bunch of erasing, all I would have to do if I make a mistake and I run out of space is simply to erase this arrow and continue my line and add more tick marks if necessary. Okay, so that would be the best technique. All right, in our case, I did it on PowerPoint. It's perfectly. Remember, when we put numbers on a number line, we put dots to represent where the number would live. And the dot filled in would go on the tick mark and on the number line itself. The dot wouldn't go above or below. It would go right on the number line. So -2 is there. We got 4 points here. 0 would be here. 3 would be here. And 4 would be here. Tonight for homework, this will be the second thing they want you to do, which is graph a couple numbers on a number line. Not a big deal. Make sense? David, make sense?
Yep.
Cool. All right. Next thing. It's basically the same thing, except they're going to use some of the previous stuff from the section. So notice the question says, graph the number and its opposite on a number line. What's the opposite of 3?
-3.
So it's really just asking me to graph 3 and -3. Since there's only 2 numbers, well, the smallest one goes on the left, the biggest one goes on the right. So I need to count up from -3 all the way up to +3. So -3, the next number would be
-2.
so forth and so on until you get to +3. Don't forget, we're asked to graph both numbers, so we would need to put both of these numbers as circles filled in on your number line. Okay? Well, there you go. There was game number 2 of 3. Questions on this one?
No.
All right. The last game is the only confusing game, right? And it still has to deal with a number line. It still has to deal with positive, negative numbers, but it's finding the distance between 2 numbers. What they're really trying to do is they're trying to get you to either add or subtract these numbers together, but you just don't realize that. That's why they have you do this seemingly strange thing. All right, but put that out of your mind for today. We'll do adding, subtracting next week. We are going to make a number line that starts at 0 and goes to -3. And what they're asking you to find is, what is the distance between 0 and -3? Now, what do I mean? And also, by the way, look, it says use an arrow diagram. So this is going to be what we call an arrow diagram. It starts off by you given 2 numbers. So I've been given -3 and 0, and it says to start at 0. Okay. Ignore that. Don't do that. Don't start at 0 to make your number line. I want you to start at the smaller of the 2 numbers. Regardless of where it says to start, I want you to start at the smallest number and make a number line that goes from the smallest to the largest. All right, so that's step number 1. You make a number line that starts at the smallest, that would be -3, and goes to the largest, -2, -1, and 0. Okay? Step number 1, you make your number line. Step number 2, now you read it. It says -3 starting at 0. -3 starting at 0. So that means for your arrow diagram, it says right here, make an arrow diagram. So it means to start at number 0 and make an arrow that points from 0 to -3. So I'm starting at 0 and I have an arrow that goes to -3. You see what I did there? The starting point is at 0 and I'm going to -3. And now all you do to get to your final answer is we simply count little tick marks. If this is my starting point, you don't need to put the dot here, and I'm going in that direction, I count 1, 2, 3 tick marks. So how far is 0 away from -3?
3.
And 3 is your answer. Now, where do you put this 3? The book places it right here, but if you want to write 3 to the other side, that's fine. Okay? So that is the process. You're like, well, won't it always be? Well, remember, we started at 0. That made this one pretty easy. You could be starting anywhere on the number line. For instance, the next one says -3 starting at 2. Once again, the best technique is find the smallest number. That's the starting point on your number line, and I go to the largest number. So I'm starting, I shouldn't use the word start. My number line begins at -3 on the left, and I count up to a +2. So -3, -2, -1, 0, 1, 2. Second step, now I read this whole thing. Now I read this statement, -3 starting at 2. It tells me where to start. I'm starting at a +2. And I'm going to -3. Now I got to count tick marks. So 2 is where I'm starting. So let's see, 1, 1, 2, 3, 4, 5. So it is 5 units away. And why were we doing this? Well, it kind of gives you a flavor of something about adding or subtracting these two these two numbers together, a positive and a negative. Notice somehow we got to a 5. There is no way, that you would have been able to tease that bit of information out without making a number line. Okay. One last one and we'll call it a day, or I think there's 2 to go. All right, so it says 2 starting at -1. So once again, the technique is we find the smallest number. The smallest number here is?
-1.
And the biggest number is 2. So I'm going from -1 to +2. So I make my number line. I start at -1. I'm going up by ones because those are the integers. 0, 1, 2. But this time, it tells me to start at -1. Before it was saying start at, come on, draw you. Before it was saying to start at a positive number. Now I'm starting at a negative number and I'm going to a positive number. So this time I'm going from left to right. But the process is still the same. I start at -1. I go all the way up here to 2 and then I count tick marks. 1, 2, 3, and there's 3 tick marks. Questions on that?
No.
Pretty simple, right? We did 3 things. We talked about positive, negative numbers, how to place them on a number line, right? We also talked about integers. We talked about absolute value. We talked about opposites. The 3 games we played were to take absolute value, place numbers on a number line, and then use the distance between 2 numbers using that arrow diagram. That is what will be on homework. So if you don't choose to do your homework like now or today, there's a chance you might forget all this stuff. Remember, I'll post the video within about a half an hour after this class is over. You can always play the video while you're doing your homework to give you a reminder of how to do the problems for homework. All right, let's see. It's Friday. We get out of here in 5 minutes, so we're going to end a little bit early unless you have questions.
I have a quick question.
Sure.
So I kind of realized while we were doing this during the absolute value.
Yep.
So whenever like the number starts at 0, would it just be the same number? Like it says 5 starting at 0, would it just be 5?
If you start at 0, yes. Absolutely.
Okay.
Right. Pun intended. All right. David, you have any questions?
Nope.
All right. You two have a good weekend. I will catch you guys on Tuesday. Be ready to shovel some snow, I hear. Supposed to get a ton of snow. Of course, the weathermen never seem to be right, so maybe it'll just be a little bit, but we'll see. All right. You guys have a wonderful weekend. See you guys on Tuesday.
Okay.
Bye.
See ya.